All right, so today we're going to do a lesson on angles of elevation and depression. All right, and when I first taught this, there was this one part of it that I actually didn't know. So let me talk. Most of this is just application of SOHCAHTOA. The second half of this lesson is actually kind of neat, but the first half is what? You're not
can't see the screen.
Sorry. All right. So first thing is this. What we're going to do is we're going to do problems like this today, where you have a person, right? We've actually done this in my Academy 1 class. All right, so let's say we have a flagpole or something, right? And we want to figure out how tall it is. You can use Pythagorean theorem to figure this out, because here's what you can do. You can figure out this angle. There's lots of ways to measure that angle. There's lots of mechanisms. If you ever watched like old time movies where they're like at sea and they have that thing called a sextant, have you seen it?
Yeah.
Right? It's a little triangle and it can measure angles. So you can measure that angle pretty accurately, okay? Within a degree or so. All right, so you can measure that angle, okay? What do you not know? You don't know how tall this is, right? So we're going to deal with this triangle here, so we're going to call this x. But what can we know here? We can't know this. We can't know this distance, right? Because we can't if we can measure that, then we can measure the flag and we're done. But we can figure out how far away we're standing. So say we're standing away 10 feet. We've actually done this in my academy class. We went outside with sextants and walked off like 50 feet and then measured the angle and then did SOHCAHTOAs here. Can you see where I'm going with this? So let's say, I don't know, this is, yeah, sure, 30 degrees, right? Make sense? Then what you can do is, that's the opposite, that's the adjacent. You see it? So you can do a TOA, right? So you can do the tangent of 30 is equal to the opposite x over the adjacent 10. So you get x equals whatever the tangent of 30 times 10 is. We just took a test over this, so I'm not going to talk about how to do that. But if you do the math for it, the tangent of 30 times 10 is about 5.7. About 5.77, all right? So the height of the flagpole is 5.77 feet. The answer is no. I'm forgetting something. So I'm forgetting about this because that's my height, right? And that's why if you look in my room, I still have that tape measure up on the corner. It's not because I want to measure your heights all the time to see how much you're growing, because we were using that for when we were doing this lesson, right? So let's say the person's 6 feet tall, right? Then this is 6 feet, and this is 5.77 feet, so that's 11.77 feet tall. See how that works? Okay. Now, instead of being a flag, let's say this is a cliff, right? A really tiny cliff, apparently. The other person's up here, right? This is an important concept in this. You would think his angle is 30 degrees, so this angle looking down is 60 degrees. This angle looking up is called the angle of elevation. And so where's the angle of depression? The 60 is what I thought when I first taught this. It's not. There's an angle. We want our math to look the same. The person looking from the cliff and the person at ground level need to do the same math. So there's an angle that is 30 that he can use. Anyone know where it is? You see it? Where?
Above the 60.
Yeah, here. Because if you kind of make that imaginary line, these two lines are parallel now, right? And this guy's angle of elevation is this guy's angle of depression. Depression is not the way you're looking at it. It's the lowering, right? Like a tropical depression, right? Or a depression in the contours of a map. Downwards, yes? So that's the angle of depression. That's the angle of elevation. What do you notice about those two angles? They're the same, so their algebra will be the same. Their trigonometry will be the same. So keep that in mind. Angle of elevation is here. Angle of depression is there. Okay? Got that? All right, so let's do a couple examples of these, and then we'll go to the cool stuff. All right, so the angle of elevation from point A to the top of the cliff is 34 degrees. They gave a picture of that. Point A is 1,000 feet from the base of the cliff. Find out how high the cliff is. Well, what is that? What is x in relation to the 34 degrees? Opposite and adjacent, right? You'll use a lot of TOAs here usually, okay? So the tangent of 34 is equal to x over 1,000. So that's easy. X is going to equal whatever the tangent of 34 times 1,000 is. You get about 674.50, right? Feet. Make sense? If my math is good. Yes, yeah. So that's the height of the cliff. Got it? All right. Another one. I'm not going to do letter A. That's the same stuff. Letter B is interesting, okay? So if you already know how tall, right, a telephone pole is, and you know how long the shadow of the pole is, you can find the angle of elevation of the sun. This is the angle of elevation, right, from ground level. So what is this? Opposite and adjacent. So the tangent of something, x, is equal to 12.5 over 18. So how do we solve this? Antitangent, right? Inverse tangent of 12.5 divided by 18. You get 34.78 degrees. All right, a ski run is 1,000 meters long. What's 1,000 meters? The ski run, that's this part, right? This red part, right? And it drops, the vertical drop is 208 yards, so that's that. So you want to find the angle of depression. Which is the angle of depression? This or this? Let's say A or B? B. So the triangle that you're looking at, now listen, a lot of people might want to do this, right? They want to redraw this triangle up here and do this triangle here. But the angle, that angle is this angle. So instead of doing it from that relationship, doing it from this relationship, because this angle will be the same as this angle. You don't have to sketch out that triangle. You can just use the bottom one because the angle of elevation is the same as angle of depression. So what do we want to find? We want to find the angle, right? So we're going to call this x. So that's opposite 208 over what? Hypotenuse. So what is that? So the sine of x is equal to the opposite 208 over the hypotenuse 1,000. So the anti-sine of 208 divided by 1,000. What do we get there? About 12 degrees? 12.01 degrees if you want to go out to do decimal places. 12 degrees would have been fine. Pretty easy? Yeah? All right. That's useful, but not nearly as useful as the next thing I'm about to show you. What does any of those kind of measuring methods rely on? That you can measure the angle, which you can always do, but it relies on one other thing. Having one of the sides. Usually, how far are you away from the thing? You with me? But what if you're trying to figure out how tall a mountain is? You can't physically count how far away you are. Maybe you could approximate that with some other stuff, but it gets pretty unpractical, yeah? This is a very simple way. So say I have a mountain, yeah? I do not know if this will be to scale, okay? And here's what you're going to do. You're going to stand a certain distance away, okay? So there's your mountain, right? You're going to stand some distance away. We'll call it x. We don't know how far we are from the mountain, but it's x. What are we going to do? Well, we don't know how tall it is, so we're going to call that y, yeah? But we can figure out this angle. So I don't know. Let's say it's 12 degrees. You with me so far? So you stand some random distance away, pretty far away, because the farther you get away, the smaller that angle is, the better the measurement's going to be, okay? So then here's the cool part. Then what you do is you go another distance away. But this time you can measure it because you can start from wherever you are and you can measure that distance. So say I go 2 miles away. Yeah? With me? Because I could measure that. Then I measure the angle again. And now let's say it's 8 degrees. I have no idea how tall this mountain's going to be, okay? Because I haven't done the actual algebra. And from here, you actually have enough to solve it using a system. Because watch. This is opposite over adjacent. So the tangent of 12 is equal to y over x. And the tangent of 8 is equal to what? Not y over 2. Not 2x. 2 plus x. Get it? Because this distance is 2 plus x. All right. Write these both in terms of y. So write this in terms of y. This is y equals the tangent of 12 times x. I can't solve that. And then I get y equals, be very careful, the tangent of 8 times, in parentheses, 2 plus x. What do you notice now? Tangent of 12 and the tangent of 8 are just numbers. Yeah? It's just a system now. This y is, just, right? These y's are the same. So then what's true? Then the tangent of 12 times x must equal the tangent of 8 times 2 plus x. This is where you're going to have to bust out with the calculator. Just find out the tangent of 12 and tangent of 8, and you can solve it, yeah? So the tangent of 12 is, someone figure out what the tangent of 8 is, so I don't have to do that one. So this is about, I'm going to go to 3 decimal places, 213x. What's the tangent of 8, someone? 0.141 times 2 plus x. With me so far? And that's just an ugly math problem, but it's solvable, right? Double that times that, so you get, what is that, 2.82, I think? 0.282 plus 0.141x equals 0.213x. Subtract, right? Minus 141 minus 0.141. What's 213 minus 141? 0.072. You following my logic? Divide both sides by 0.072. Divide by 0.072. You get x equals whatever the heck that is. 0.282 divided by 0.072. You get 3.92. What is that? What is that? That's this. That's the distance you were from the mountain. Yeah? 3.92 miles from the mountain when you measured it, yeah? That's not what y is. We want to know how tall the mountain is, right? So how do we solve for that now? We plug it in here, right? The tangent of 12 is equal to, we don't know y, but we do know x, 3.92. So y is going to equal whatever the tangent of 12 times 3.92 is. And that's really cool, right? You could definitely do this in real world. And you get 0.833, yeah? Which is what? Yeah, it's about a mile high. That's actually pretty high.
Yeah.
5,280 feet. That's the mountains in El Paso. When I lived in El Paso, they were much higher than that. So it's a big mountain. It's a big mountain. All right. Make sense how this works? Okay. So that's probably the most useful one. And throughout history, they have used this for measurements of things in the real world, right? When they were going around National Geographic, which was not a magazine back in the day, but an actual exploration society, and they were trying to figure out what the biggest mountains in the world were, they were using math like this, okay? Very similar to this. And the more accurate you are, what's going to happen? The better your estimation. Yeah. They do this these days now. They don't do it like this. They use lasers, right? Because lasers can give you an exact distance. Yeah.
How do you find, the angle's just gonna be given to you?
You would measure it, and you could measure that angle, right? You'd go to eye level, and you'd use the, here, I have enough time, right? I have 20 minutes still. We actually made very crude ones in my class one time. This is very crude, but it's the exact same idea. You would just make it very carefully, right? So you see how, right? I put a protractor on two, right? And then all you do, put it at eye level, right? Try to get this parallel with the ground as best you can. And then you move it up till you're touching it, right? Wherever the top of whatever that is. And then you just read the angle. Make sense? Is it close? Yeah. But it's not exact, right? The more exact your instrument, that's why a sextant, when you were piloting a ship, was so important. You didn't want to lose that thing because that thing was your accurate readings of you could chart where you were in the cosmos, yeah? So, all right. All right, we're not going to do all of these. We'll probably do like one of these because they do take a while. Let's just do the first one. Example 3. You're trying to estimate the height of the garage. Jason sites the top of the garage at 42 degrees elevation, right? So he's saying this part right here is 42 degrees, right? Right, that's 42 degrees. He doesn't know how far he's standing away. Then Jason steps back 20 feet and he measures again, it's 10 degrees. Get the idea? All right, so first thing you do is you deal with this triangle, right? You deal with this triangle first. So what is that? Let's see, what's the formula going to be? The tangent of is equal to x over y. That's my first equation, right? The tangent of 10 is equal to what? X over 20 plus y. That's where people mess up, right? All right, cross multiply, you end up with x equaling the tangent of 42 times y, and you end up with x equaling the tangent of 10 times 20 plus y, right? What can you do with that? Those x's are the same, right? Because that's the height of the building plus your height, because you're forgetting that you're doing it at eye level, right? So you can make them equal to each other. So the tangent of 42 times y is equal to the tangent of 10 times 20 plus y. That's where we got to figure out what the tangent of 42 and the tangent of 10 are. Someone help me out with the tangent of 10. I'll do 42.
0.176.
All right, so this is 0.900y. And what'd you say?
0.176.
176 of 20 plus y. I don't mind if you use a calculator on this, okay? 0.176 times 20 is 3.52. So 3.52 plus 0.176y. The more accurate you are, the more exact your answer will be, yeah? All right, so we get 0.9 minus 0.176. So we get 0.724y equals 3.52. Then what? Just divide. I don't care that it's ugly numbers because I'm going to let the calculator do the work. You get y is about 4.862. What is that? 4.862 what? Feet. Okay, what is 4.862? That is how far you were from the building, right? So how do I solve for x now? Go back to the original equation, right? So the tangent of 42, I think, was 0.900, right? So 0.900 equals x over 4.862. So all I have to do is multiply 0.9 times 4.862. I get x is about 4.376 feet tall. It's like a midget garage, right? Sorry, little people garage. Right, that is not the height of the garage. I'm forgetting that I measured it at my eye level, which was 6 feet off the ground. So I got to add 6 to that. So now it's at about 10.376 feet tall, and that seems reasonable for a, yeah, the height of a building, yeah? Incidentally, I think we measured these walls one time using this, and I think we decided it was like 13 feet or something like that. So,
That's pretty cool.
and there are nice ceilings. They're good for hanging things from, huh? Fun little fact. Back in the day when I had my portable, you know, the portables had pretty small ceilings, right? So I wanted to hang stuff from the ceiling. So one day the fire marshal came in and he said, "You can't have things hanging from your ceiling. It's a fire hazard." You know, despite the fact that my room was made out of wood panels and it's basically a big firebox, okay? That wasn't the problem. It was me hanging things from the ceiling because apparently that was going to make it go up in flames, right? So he wouldn't let me. So you know what I did? I hung the shapes directly right below the ceiling, which is how this happened. I'm not allowed to hang things from the ceiling, right? Those are because I just haven't even talked to them about it. But if those got lit on fire, it'd just be cool, wouldn't it? Fireball, fireball. All right, that's all there is to this. I'm not going to do another one because it's the same math, yeah? Just more of the same. If you want me to do another one, I'd be happy to, but are we okay with this? Just set up the algebra and let the algebra do the work, yeah? All right.